Here's midterm 1 for fall 2021. Starting with question 1. Which of the following print statements placed on line 20 in the program above would generate output as presented on the right? So we're going to insert a printf line right here. So if I was in a rush to take this exam, I might make the assumption that this value is correct, but just in case the answer is none of the above, we can do a quick check. So looking at our program, we see we have a mix of ints and floats, so we want to be really careful about data types. We also have this defined constant pi up here. So what are we printing? We're printing surface area. So surface area equals pi times radius. And then on line 15, we're going to also multiply it by radius plus slant. Because we're assigning the right-hand side to a float on the left-hand side, I'm not really worried about doing it line by line. If that was an integer, I would be more careful about that for any information loss through conversion by assignment. But in this case, I can combine 14 and 15, lines 14 and 15 into one long line. So pi times 5 times 5 plus 15. Remember, this is both lines 14 and 15 combined, which simplifies down to pi times 5 times 20, or pi times 100. So I know that surface area is equal to the defined constant, just move over the decimal place by 2. And then because we're using printf, it's going to round our result. So that's why it's 0.16 and not 0.15. So just in case we were worried about the answer being D, now we know that it's not, at least not for the reason of the value. Now we're going to look at the formatting. So I always start by counting the white space by using the reference characters up above. I do this by creating vertical lines. So 1, 2, 3, 4, 5, 10 white spaces. Six characters, remember we include the decimal point, make up this number. And then there are 2 digits past the decimal point. So what can we find from this? Well, looking at our options, we see that there's no hard-coded spaces between the colon and the percent sign, which is something you always want to be careful of. So all 10 of these white space, as well as the 6 characters making up the number, need to be part of our width modifier. So therefore, we want to reserve 16 spaces. We want to display 2 digits past the decimal point. So our answer is B. Going on to question 2. Which of the following is the output generated by line 21? So once again, we want to be mindful that we're mixing ints and floats together. So now we're looking for volume. So we really only care about lines 16 and 17 because we're not using surface area in this calculation. So volume is equal to pi, but casted to an int. So remember that casted to an int, we lose any information after the decimal point. So it's just 3 times radius, which is just 5 int, times radius, times height is a float, 3.16. And then because the left-hand side is a float, we're not going to be losing any information, which I like to write as a reminder. We're not going to be losing any information from the right-hand side calculation. As a result, I can also include line 17 in this one line instead of doing the calculation step by step. But keep in mind, you can't always use a shortcut if volume were to be an int, because of the conversion by assignment that would take place before evaluating line 17. But if you know these tricks, it can help you move along through the exam more quickly. So this right here is lines 16 and 17 combined. Quick math, I'm going to cancel out the 3's. That's going to be 25 times 3.16. And because volume is a float and not an integer, we do keep anything after the decimal place. So therefore, our answer is going to be 79. This is not because it was an integer, but it just happened to be that there's no, it's a whole number. It's not anything after the decimal place. no fraction remainder. So the answer is A. Looking at question 3. Which of the following statements regarding high-level programming languages is false? A. High-level programming languages are portable to many different computers as they do not rely on specific hardware. So, this one's going to be true. Borrowing elements of natural language, such as familiar terms, is one aspect that makes high-level programming languages easier to use. This one is also true. So high-level programming languages, things like Python, right? Obviously, you still need to know the code syntax, but it reads a little bit easier. Even if you didn't know how to program, you could kind of figure out what things do based on how it looks and what the words say, do, while, for, whatever. C. High-level programming languages bridge the natural languages and machine languages without the need for a compiler. So this one is not going to be true. Some high-level programming languages still need to be compiled. This is talking about interpreted languages, which is a little bit different concept. So C is false. All right, question 4. Which of the following is the output generated by lines 20 and 21? So we're looking for x, y, z, and pi. Or excuse me, we're looking for just x and y. So let's find x and y. X equals pi, a defined constant, times 10,000. And notice that x is an int. So I like to write that on the left side as a reminder. So pi times 10,000, we're going to move over the decimal place by 4. And so it's going to be 31415. Now, of course, pi times 10,000 is really 31,415.9265, but because we're converting it to an int by assignment, we're going to drop any information that's on the right-hand side after the decimal. And so if you watch my videos on questions 1 and 2, you'll see that I combined multiple lines of code into one long equation because I was assigning it to a float, so I didn't need to worry about information loss. Because x is an int, we need to solve this line by line, or else our answer will change. So x is equal to 31415. Now x mod equal 100. So after you divide by 100, what is the remainder? Well, anything that's in the last two digits, so 15. And then x divide equal 2. It's going to be 7. Once again, remember that it's an int on the left-hand side, so we have to convert the right-hand side, which was 7.5 to match. Or actually, in this case, excuse me, it would be 7 divided by 2, and divided by int. The result already will be an int. So x equals 7. Then y equals pi plus 0.0005. But note that y is an int. So we can add this to pi, but it's not going to change what the whole number is. And we don't care about what's after the decimal point because it's going to be lost in assignment. So I'm not even going to figure out what that addition results to. I just know that y equals 3. Then y times equals 1,000. 3 times 1,000 is 3,000. So jumping down to line 21, we're going to substitute in the first value, or variable, x, for this star right here. Remember, this is going to be our width modifier. And then the second one is going to replace the value. So we want to display 3,000 with a width modifier of 7. Now also note, again differently than questions 1 and 2, that we have a hard-coded space right here. One space is actually in the code between colon and %sign. So when we're looking at our answers, we're going to start counting our 7 spaces for the width modifier after the first hard-coded one. So now I'm going to count 1, 2, 3, 4, 5, 6, 7. Well, perfect. that number is all the way to the right-hand side of our reserved space, so the answer is going to be A. We know that our final result is 3,000, so it can't be the others. Question number 5. Which of the following is the output generated by line 22? So now we're looking for z and pi. So z equals pi casted to an int plus 0.9. So when we cast to an int, we drop any information after the decimal point. So that's just going to be 3 plus 0.9, which would be 3.9. However, z is an int, so we need to make the right-hand side match the left-hand side. Well, we're going to convert 3.9 to an int, so drop everything after the decimal point. Z is just 3. So, with a width of 3, we're going to display pi as a float, or as a double, really, because we have LF this time instead of D. So, excuse me, not with a width, that's going to be with a precision modifier of 3, because it comes after the decimal point, the star. So we're going to display 3 decimal places, which is going to be C. 3.142, because we round the last digit when using printf. Question number 6. Which of the following statements regarding constants is false? A. A literal constant is an unnamed constant used to specify data. This is true. So a literal constant can be A. It can be 123. Right? These don't have names. They're just values we hard-coded, essentially into the code. We type them out. They're not stored in a variable. So it could be a conversion rate or some other logic to find our answer. B. While values stored by variables have a data type, the values represented by constants do not. So this one is going to be false. Right, already we can see A is a char. It obviously has a type. 123 is also a number. In this case, it would be an int. A decimal would be, if you typed in a decimal constant, it would be assumed to be a double by the compiler. So they do have data types, even if it's not explicitly declared. Therefore, B is false. C. The command to create a defined constant is usually placed at the beginning of the program. This one is true. Right, that's just a course standard of how we do it in 159. Even like the example up here, we can see we have our include statements, but then immediately after, before our first function, we already have our defined constants laid out. So C is true. Therefore, the B is false, and B is our answer. Number 7. Which of the following correctly describes the use of the size modifier in the placeholder of a printf statement? So again, remember when we have these statements, we have different modifiers. So it could be 7.3 LF. 7 is our width, 3 is our precision, and LF is the size modifier, meaning how do we want to display this data, what type of data. So LF means that it's going to be a double, so we're going to keep the decimal values when we display it. So A, the size modifier is used to specify the minimum number of positions to reserve. No, that would be the width. B, it indicates the number of decimal places. No, that's going to be the precision. And C, the size modifier is needed when displaying the longer types within the integer and floating point families of data. That is true, because again, we say, do we want, no matter what the value is, do we want to display it as a double, or do we just want to display it casted to an integer? So that size modifier determines that. So therefore, C is the correct answer. Question number 8. Which of the following is the first line output? So what is value of x? Well, this time we're working with all float variables, so keep that in mind. However, within our calculations, we can see that we are still having some int literal constants. So we have to be careful about how our math is working. So looking at this line right here, x equals 9 divided by 5 times 7.2 plus 32. Well, following our precedents, kind of like order of operations basically in this case, we're going to do the division and multiplication first, then the addition. So working left to right from our division and multiplication, 9 divided by 5 is going to be 1. Because an int divided by an int needs to result in an integer. So whatever was in the decimal place, you might think it's 1.8. We don't care. We just drop that all. It's just 1. So the next step is going to look like this. 1 times 7.2 is 7.2. 7.2 plus 32 is 39.2. So x is equal to 39.2. Now question 9. Y plus equals z times 5 divided by 6. So y equals 2, its current value, or 2.0 really, plus z, which is 3.0, times 5, divided by 6. Notice that I wrote 3.0 and not 3. Be very careful about this. If it helps you out, when you first see a problem, you can add the decimal places after all your values that are floats or all your variables, just as a reminder. So 3.0 times 5 is 15.0. A float times an integer will keep the higher data type, so it's going to stay as a float. So 15.0. 15.0 divided by 6 is going to be 2.5, because again, we're keeping that higher or more detailed, as I like to call it, data type. So that's going to be 2.0 plus 2.5. So y equals 4.5. All right, now moving on to question 10. What is z? Well, z equals the current value of z, so 3.0 divided by x constitute int. Excuse me, that should be 39.2. And y constitute int. Forgot to put my previous answers up there. So z equals 3.0 divided by 39, because we're losing any information at the decimal point, plus 4 equals 3.0 divided by 43. And we can see that we have a precision modifier of 1 in our printf, so we only care about what the first decimal place is. Well, 3.0 divided by 40 is going to be roughly So on the exam, you would have to do some quick math with this, which is not ideal. But if you went through the calculator answer, you would find that this is 0.0697 approximately, and our printf would round it up, so it'd be 0.1. So in this case, you know that these answer choices are pretty far apart, so if you're getting in your quick math in your head or on paper something close to 0.1, it's probably safe to assume. If you could do the longer division, that'd be great too. But basically, your answer should be a little bit above a half, or sorry, 0.05, 0.06, 0.07, and so then you'd be rounding it up for the printf. So our answer is A. All right, questions 11 and 12, we have some prefix and postfix increments and decrements. So remember that if it comes after the postfix, we're going to evaluate the expression first, and then as a side effect, we make the change. If it's prefix, we make the changes to the variable first, then evaluate the expression. So, starting with this first line here, z plus equals pow x plus plus, it's postfix, so we care about what is x now. Y minus minus is postfix, so what is y now? 3 cubed is going to be 27. As a side effect, we increase x and decrease y. Now we have plus plus x, so we're going to make the change to x first, use the new value. We have a postfix minus minus, so we're going to use the value now. 5 cubed is going to be 25, so z is now 52. As a side effect, we decrease y by 1. Now we have x plus plus, it's a postfix, so we care about what is x now. Minus minus y prefix, so let's make the change first, then use the new value. 5 to the 0 is going to be 1, so now z is 53. As a side effect, we increase x to be 6. Now we come down here, we have printing, we have plus plus x, so make the change first, use the new value. Minus minus y is a prefix, so make the change first, use the new value. So we're going to print out 7 and negative 1, and then z is going to be 53. So again, just be careful, this question is tricky because we also have those changes made in the printf statement itself. All right, question 13. Which of the following is the first line of output generated? So we're looking at upper alpha at line 11. So for now, we don't care about what's down here. So upper alpha equals g, then we're going to pass it as a parameter to this change character function. So alpha equals g, result equals g minus a. Well, we know that all these, if you look at the ASCII table, you could also find this, but we know that all the letters are in order. So g minus a is just going to be the number of letters between a and g. So g is the 7th letter of the alphabet, a is the first. So whatever the difference is will be equivalent to 7 minus 1. So result equals 6. 6 divided by 13, int divided by an int is going to be 0. We don't care about the remainder or decimal, fraction, anything. It's just the whole number value. So result equals 0. And then the result is equal to negative result times 13. So 0 times 13 is 0, plus 1 minus 0 times 13. So this is kind of our selection by calculation right here. So 0 times 13 plus 1 times 13 is going to be 13. Now we're going to return g plus 13. So our current letter is g. We're going to add 13 or go 13 letters later in the alphabet. So that would be t. So we return t. Now upper alpha is equal to t. And our answer is C. Moving on to question 14. Now we're going to evaluate the rest of the program. So let's free up that space and reset our work down below. So from the last question, we know that upper alpha is now t. So we're going to, but in this case, it actually doesn't matter. So we're going to pass q. So result equals q minus a. Well, q is the 17th letter of the alphabet. A is the first, so 17 minus 1 is 16. So result equals 16. Remember that the ASCII values of q and a are not 17 and 1, but they're spread out by the same interval. So I don't need to reference the ASCII table, but if I wanted to, I certainly could. 16 divided equal 13 is 1. Again, we don't care about the decimal or fraction because it's two ints dividing, so the result is an int. So -1 times 13 plus 0 times 13. So we're going to return -13 plus q, which is going to be the fourth letter of the alphabet. Because we were at the 17th, we're subtracting 13 letters, so now we're the fourth. So our answer is going to be capital D. So with both these questions, again, feel free to use the ASCII table on the back of your exam, but if you know these shortcuts, you can save some flipping back and forth and ultimately gain back more time on the exam. Question 15. Which of the following statements regarding postfix and prefix expressions is false? A. The value of the postfix increment expression is determined after the variable is increased. So again, remember postfix is our x plus plus, y minus minus, stuff like that, where the symbols come after. So that one's going to be false. We evaluate the expression, and then we make any changes to the variable afterwards. It's kind of like a side effect. So when we're, if we say x equals, let's see, y minus minus plus 4, right? We're going to say, what is the value of y right now, and add 4. Then when we're done, we'll subtract 1 from y. But we only care about what is y right now. Now, B, multiple applications of a postfix increment to a single variable in an expression is undefined. That one's true. C, the operand in a postfix or prefix expression must be a variable. This one is also true. You can't do like 5 minus minus or anything like that. The operand expressions are supposed to be applied to something that can be changed, the value that is stored, basically. There'd really be no meaning to plus plus 4. So, it's not even something you would want to use. But anyways, A is false. A is our answer. 16. Which of the following statements regarding data type conversions is true? A, the first use of an explicit type conversion will alter the data type of a variable for the remainder of the program. So this is something like saying int x equals 4. Now, let's say y equals float x. So all we're saying is y equals 4.0, but x itself, the variable, does not change just because we converted it in one spot in the program. We can't change data types like that in C, at least not in this course. And so this is just basically, it only applies for that line, that specific use of x right there. So A is false. B, an assignment conversion will always result in the promotion of a lower ranked data type to that of a higher ranked data type. So this one's going to be false. Remember, assignment would be something like saying, let's say int x equals 4.5. So our right-hand side is a float or double, something like that, and the left-hand side is an int. Well, we always want to make the right-hand side match the left-hand side, because that's all we have space and memory to store. So we drop the information after the 0.5, which means we're demoting the information. So therefore, we are going to a lower ranked data type, and B is false. C, implicit type conversions are made to all operands in an expression before any individual operator is evaluated. So this one is going to be false. So implicit data type conversions would be something like that 3.0 times 5, we're going to promote the 5 to be a 5.0 when we evaluate the multiplication. We just do that as we get to it. It's not something that we're going to do when we get to the actual operation, which in this case would be the first step, but we're not going to do it at the start. So this allows us to do 4 plus 15.0 instead of, because by the time we get to the addition, we've already done the multiplication. So C is false. So therefore, the answer is D, none of the above. Question 17, what is the first line output generated by the program above? So we're looking for X and Y. So we have a lot of these increments and decrements. We have to be careful about what is postfix, what is prefix. So we have three int variables. And then we're going to do z equals change values, x minus minus plus plus y. So remember our postfix, we say what is x right now. Our prefix, we change y first, then use the new value. So going down to change values, temp equals 10 divided by 5 equals 2. Temp times equals x minus minus, postfix. So what is x now? X is 10. So now temp equals 20. As a side effect of line 27, we're going to decrease x. Temp plus equals 5 divided by 9 times 5. So 5 divided by 9 is going to be 0, because an int divided by int needs to be an int. And then times 9, well, 0 times, excuse me, times 5, well, 0 times 5 is 0. So temp plus equals 0. So we're going to return 20. So now z is equal to 20. And then don't forget, as a side effect, on line 11, we have x minus minus. So now we need to decrease x. And then we continue this process 3 more times. So line 12, we're going to pass minus minus x. So change the value first. Plus plus y. Change the value first because it's prefix. 8 and 6. Right, maybe you start to get the hang of this. It's going to be 8 divided by 6 is 8 greater than 6. Basically is what we're looking for. Well, yes, so it's going to be 1. Uh, 1 times equals x minus minus, so times 8. Now that we've evaluated that, we can decrease x. Temp plus equals y divided by x. 6 divided by 7 is going to be 0. 0 times 6 is 0. So we're going to add 0 to temp. Return 8. So now z is 28. On line 12, both of our increments and decrements were prefixed, so we don't need to do anything extra before moving on to line 13. So line 13, minus minus x, so change it first. Y plus plus, it's postfix, so what is y now? Well, it's 6. Going down to our change values function, we have 7 and 6. Temp equals 7 divided by 6 equals 1. Temp times equals 7. As a side effect of this line, now we decrease x. Now temp plus equals y divided by x. 6 divided by 6 is 1 times y, which is 6. So temp plus equals 6. Now it's 13. Notice that this behavior changed now that y caught up to x, basically. So line 28 actually did something. Now we're going to return 13 back, increasing z to 41. This line, line 13, did have a postfix, so now we need to increase y. And now we can move on to line 14. X minus minus, postfix, so what is x now? Y plus plus, postfix, what is y now? Evaluate this function, 7 and 7. Temp equals x divided by y equals 1. Temp times equals x minus minus, so times 7 is going to be 7. As a side effect, we decrease x. Temp plus equals 7 divided by 6 is 1. 1 times 7 is 7. So now we increase temp to 14. We return 14 back, and now z is 55. Once again, line 14, we had 2 postfix operations, so we're going to decrease x now and increase y. Therefore, final values for these variables are 6, 8, and 55. So our first answer for 17 is going to be D, none of the above. And for 18, it's going to be B, 55. Now move on to question 19. Which of the following statements regarding variables and functions is false? A. Parameters are defined in the first line of the function definition and are not to be redefined within the local declaration section of the function. So this one is going to be true. So remember, the first line of our function definition is going to have return type, name of the function, parameters, and then our functions inside the body, right? And so x1 and x2 are already declared in this first line of the function, so we don't need to declare them again inside. That would run into some issues. So A is going to be true. B, a local variable cannot be referenced through its identifier outside of the function in which it is defined. This one is also going to be true. So if we have our function over here, do thing, that has x1 and x2, and I have some other function over here, and I want to do, y equals x1, that's not going to be the same variable in both. The x1 in one function is not the same as the x1 in another function. It will be its own local variable that needs to be declared. So B is true. And this is the whole idea of scope. C, a variable declared in the local declaration section of a function can have the same identifier as one of the parameters of the same function. So this is going to be false. We can't say now, double x1 equals 123.45, right? We can't create another variable with the same name as one of the parameters because those are two variables with the same name in the same space. So how does the program know whether you want to talk about the int or the double when you're doing something else with those variables? It doesn't. So that would be a big issue. So C is false and is our answer for 19. All right, now we're on to question 22. So which of the following is generated on line 13? So we have these nested function calls. So remember, we always want to work on the inside and start on the inside and work our way outwards. So looking at this first call, make changes, y comma z, so 19 comma 14. Jump down to our function, x equals 19, y equals 14. Of course, remember that the names here and make changes are x and y. It doesn't mean that it's going to be the x and y that we had in main, it's just whatever we pass to it in the same order. So, anyways, going down to line 28, x minus equals y, so 19, x equals 19 minus 14. That's going to be 5. Y plus equals 5, that's going to be 19. Now we're going to return y minus x. 19 minus 5 is going to be 14. So now we're going to do this bigger function call. Make changes, x, which is 11, comma 14. So x, comma 14, or 11, comma 14, excuse me. So x minus equals y, x is negative 3, y plus equals x, y is 11, return y minus x, that's going to be 14. So this whole thing right here is going to be 14, so x equals 14 now. All right, so our answer is B for 22. And 23, we're going to look at lines 15 and 17 now. But before we do that, let's look a little bit more at our code. So in solving question 22, we just kind of brute forced our way through the code, plugging in our parameters and all that, but we didn't really look at what is this make changes function. Once again, if you don't recognize this, that's okay. You can always just, run through every bit of the code, but this is a great way to save time by really understanding what the code is doing. Well, we have these two variables. Right, in line 28, we make these changes to x. and then we do y plus equals x, but then we return y minus x. So are these two lines, line 29 and 31, basically canceling each other out? We don't change y at any point except for line 29, and then we basically undo the change as we return the value. So if you noticed, in line 11, when we passed 19 and 14, we got back the second number just as it originally was, 14. Then when we passed 11 and 14, we once again got the second number, represented by y in the make changes function, back as what it originally was. So really, this function is doing nothing but returning the second parameter. So this time, I'm not going to actually plug in the numbers for question 23. I'm going to look at my make changes call right here, and I know that whatever the second parameter is what is returned. So now y equals negative y, so y equals negative 19. We're going to print out negative 19, so C. Now on to question 24. Once again, we're going to use the same shortcut we observed for question 23. So make changes 2, 4. Well, it's whatever this second number is. So this first call simplifies to 4. The second call simplifies to the second number, 4, 3, so it's going to be 3. And the last call, well, our input is 1, 3, so our output is going to be the second number, which is 3. Therefore, z equals 3. Our answer is C. Alright, so this is a good example of a problem that I find easier to look at first and kind of translate to a little bit more English or the way that I understand programs, and then jumping into the actual program execution. Right, so we're going to call this change values function 3 times. I'm going to rewrite line 23 to be the value at address C plus equals y mod x. And then we're going to also return y mod x. So really, what are we doing? We're looking for the second parameter mod the first. We're going to increase the third, or sorry, we're going to set the third variable equal to that, and we're also going to return that value. So, looking at line 11, we have b mod a 30 mod 21 is 9. So that's going to be the new value of a. We're also going to increase c by that number, so from 18 to 27. Now at line 12, we have c mod b, 27 mod 30 is 27. So it's going to be the new value of b. We're going to increase a by that amount. Finally, we have a mod c, 36 mod 27 is going to be 9. That's going to be the new value of c. We're also going to increase b by that amount. Right, so you could of course go one by one and jump down between the function and back to the main with your parameters, but kind of understanding more what is going on and rewriting some lines to be a little bit more clear can help speed this up. So we know that a is 36, so 25 is going to be a. B is 36, C is 9, so 26 is going to be C. Question 27. Which of the following statements regarding control of a program and function calls is false? A. The sequence in which the statements are executed in a program can be altered through the use of functions and function calls. So that's true, just like the code above, right? We don't read this top to bottom. We know that when we have a function call like here, we jump down, then at the end of the function we jump back up, we jump again, right? So we're not going sequentially. So A is true. B, the declaration of user-defined functions in the global declaration section of the program will permit any function to call any other function in the program. That's going to be true. Just like we put our defined constants up at the top, we put the function names up at the top so that we can use them anywhere in our program. C, the control of the program always returns from the called function to the main function. So the key part right here is that it's going back to the main function, which is false. Often we call functions from the main, and so they do happen to return to the main, but really they're only returning to wherever they were called from. So if we had one function calling another function, right, it's going to return back to the original function, not all the way back to main. So C is false. Therefore, C is the answer. Question 28. Which of the following statements regarding passing by address is false? A. Given the address of a variable, the called function can access and manipulate the value of a variable in the calling function. This one is true, right? Just as we did up above, by passing star this pointer, so we have star z, right? We're able to change the variables in main by using the address. B. The called function must declare a special type of variable known as a pointer to store a memory address that is sent from the calling function. That is also true. That's what our star z is up above. C. When only a single value needs to be returned to the calling function, then we should use the standard return statement rather than passing a single parameter by address. This is also true. So if you only have one return value, just use the return statement. We don't use pass by address unless necessary, because we want to avoid making accidental changes to variables and other functions, because it's a little trickier to debug. It also allows our code to be more organized, and we can use, in some cases, the return value in a conditional expression, which kind of opens up some more opportunities for cleaner code. So that's best practice. Therefore, answer is D, none of the above, because A, B, and C are all true. Question 29. How many of the 7 unique UDFs called within the main function above are void? Well, what does a void function mean? A void function means that we are not returning any result at the end. Or if it's happening, it's through pass by address. So, looking at our UDFs, we're looking for functions that are not, the return result is not assigned to some variable. Well, with getAngle, we have this equal sign, so it can't be that. Same thing with getMass and distance, with calcSide, and with the two calc attention functions. However, we do have display results where there's no left-hand side. You know, it's not saying that some variable is equal to the result of display results. So it could be still return and enter some value, and that we're just not setting it, storing it anywhere. It could be a void function where it's not returning anything. Often our output functions are void. So we're going to say A, only one unique function is void. 30. Which of the following declarations is incorrect for the getAngle function based on the main function provided above? Well, looking up above, we have angle1 and angle2 are ints, and we know it returns something because of this assignment. We know that it's receiving one number that is at least of int size, maybe more detail. So looking at our options, all three return ints, and then, right, we have int and int, so it's going to be able to receive a number, and we have this constant. Well, we know that our function declaration needs to have the different types of parameters. The names are optional, but at least needs to give the type. C would be incorrect because it's only giving a value. So therefore, our answer is C. And then for question 31, we're looking for a function declaration for calcSide. Well, we know that it needs to return an int. It's receiving a double int. And then this all simplifies down to a double because we're going to keep that highest detail, as I call it, or precision, from that 180.0. So, return an int, receive a double, int, double. Therefore, answer is A. Obviously, some of these other ones would work, but you'd be losing information in the process, or it just wouldn't be the best fit. Question 32. Which of the following does not describe a necessary condition to pass parameters by address to a function? A. The number of function calls in a program can be reduced through the use of passing more parameters by address. So A is not a necessary condition, at least. So this is the answer. So the reason why, right? You could reduce your program down to essentially one UDF, by using pass by address if you combined all your tasks together. But that means you would be passing unrelated parameters and changing lots of things across different functions, which would be really confusing and not well organized. Then as soon as you tried to change the way your code worked, especially if you wanted to change the order, it would be extremely difficult. So this would violate the coding standards that every function should execute one task only. B, more than a single value changed or calculated in the called function is needed in the calling function. This one is totally fine. It's a great time to use pass by address. So let's say you're returning a coordinates back from your function. Then you have an x and a y, or an x and a y and a z. Obviously, you can only return one, the normal method. So you would have to use pass by address for at least 2 of the 3 coordinate planes. C, the called function completes only a single task of the larger problem being solved. That is totally fine. Like I said, as long as your functions each complete one task, if you need to use pass by address to make it do the task properly, that is okay. So our answer is A. Question 33. Which of the following statements regarding the activities of the preprocessor is false? A. One purpose of the preprocessor commands is to make substitution in the code. Well, think of your hash define. That's part of your preprocessor directives. That's going to be true. B. Actions specified for the preprocessor are applied to the program after a successful attempt to compile. Well, remember that this is a preprocessor, so things you do first. So this is going to be false. It needs to happen before compilation. C. The preprocessor can be used to provide access to the standard library functions and constants within a program. Well, that's going to be your hash include lines. Once again, those are going to be preprocessor directives. So for example, you would include std lib.h, right, your standard library. So C is true. Therefore, our answer is B. Question 34. Which of the following is not determined by the data type of a variable or value? A, the amount of memory necessary for that value. That one is going to be true. So remember, we kind of have our base types, as I call them, the floats and ints. And then we move on to doubles and longs, and keep building up to larger and larger types of variables, right? And so every time you build up another layer, you're increasing the amount of memory needed, because you get basically more detailed, as I call it, with more places after the decimal point, or a higher number of digits possible. So A is going to be true. B, how a value is retrieved from or stored to the memory of a variable. That one is also going to be true. So right, we have the amount of memory that it's has reserved for it. We have how the bits in memory are configured. Does the first bit represent a certain place in the number? Is it represent a decimal? How is it ordered? Right, that all depends on the data type. C, those operators which are applicable is also going to be true. Obviously, we can't do modulus with non-integer variables. So, right, if it's something that's a float or not, or double or not, right, we'll change what type of operators we can use. So C is true as well. Therefore, the answer is D, none of the above.